it work? Let's look at an example of an organized space, a supermarket. Try to understand how does it work. So for our purpose, it's a building with special floors. One floor is for storage, where the assorted feed of raw products arrive from conveyor belts or supply trucks outside. Then there's a floor for the processing of products by the supermarket workers, for example, adding labels, grouping together products. Then there's a floor where the products are displayed in an organized way so that shoppers can easily find and discover the products they want to buy. So it's a building with special floors for the organized space, the product processing, and the assorted feed of raw products. So three components make this supermarket example work. Start with a building with special floors. We have the workers that do the processing, and we have the knowledge and training required for the workers to do all this. So make the web-wide metrics and our need to generalize a way to process content feeds into easily consumable organized spaces, we also need three basic ingredients. One is a common way to access and browse both content feeds and organized spaces. So basically, a place to store the content feeds, store the interim stages of processing them, and store the organized space resulting from that processing. Two are the machine workers or software that actually process the content feeds and convert them into organized spaces. And three, we need a way to capture that knowledge, a way to teach the machine workers how to process any content feed into an organized space. We call these ingredients the matrix model, resident hackers, and training course. So the matrix model is basically a protocol for storing and accessing data, and it's based on a spatial model inspired by cities, kind of a 3D environment metaphor. So there's a ground floor, we call it G. Over the ground floor, we have data containers to store the data items. We call them buildings. Their address are the coordinates on the ground floor. So a building can be atomic, containing just one data item. For example, the JSON document representing a Twitter post. Or building can be composite, made of multiple floors. A floor can contain more buildings, nested building, and this can go on and on. So let's look at an example. For example, if we need to store my Twitter feed from today and its processing, we start with the floor to contain the raw tweets from the feed. We then have a floor to contain the article linked in the raw tweets. Then we have a floor for the concepts and topics that we extract from the articles. And finally, we have a floor where the tweets are presented in an organized space. So this is the matrix model. It's a common way to access and browse both content feeds and organized spaces. Second ingredients are the resident hackers. So since we don't have enough time to consume all the content feeds we subscribe to, we need machines to do that for us and produce the organized spaces. So we call these the resident hackers, and they are hungry and foolish bots that live inside the matrix model and do the processing for us. So they do that by basically moving from building to building and applying actions to the data inside the buildings. We use sensors to do that. For example, they have virtual smell emitted from buildings containing unprocessed data. And the actions they apply on data are basically public APIs they find on the web for doing the processing. So when applying actions, the actions have some output which is used either to add data to buildings or create new buildings. This results in a processing pipeline. The resident hackers start with like basic knowledge of how to do things, but using user feedback, they improve over time and learn how to apply the right actions to any data. So these are the resident hackers, machine workers that process content feeds and convert them into organized spaces. Third ingredients are the training courses. So these are basically code documents specifying the seed knowledge of how to process a certain type of content feed into an organized space. So these are meant to be very simple to write, so anyone can develop these training courses. The structure of a training course is a set of behavior rules. So they explain how to take an input building, extract an input from it, apply some action on that input, get the output of the action, and create a new building and get some positive or negative reward for that. And when choosing a content feed to process, the user can tell his resident hackers which training course to use. For example, you can search for training courses to process Twitter feeds. Or you can just let the resident hackers choose a training course by themselves. So these are the training courses, an easy way to teach machine workers how to process any content feed into an organized space. So how does it all work together? So we start by the user choosing a training course for his content feed. We then have a building created for that content feed in the Metrics Cloud. Then we need to start streaming items from the content feed into that building using something we call a data pipe. Then the resident hackers start processing the content feed using the knowledge from the training course selected. Finally, the user browses the organized space generated using a software we call the Metrics Browser. So this is like a brief schema of how the web white metrics work.